Hello and welcome to the course of Advanced Control System. This is basically an MTech course of mechatronics. The first unit is time and frequency response, and the topic is Introduction to Control System. The control system has become essential ingredient of modern technology. You can everywhere find from medicine production to space shuttle vehicle, from biological tools to other fields of agriculture, you find control system. So in the next slides, we will discuss about control systems. And first we will tell what is a control system. Then we will talk about why we need control systems. And we will talk about the examples in nature, in industry, and wherever we find examples, we will put forth to you. Then we will briefly discuss the concept of control system, the main funda of the control system of input and output. Then I will give you a brief history of control systems, and then we will talk about why we need control systems. And the basic component of control system will be covered. And then we will give a brief introduction about open loop control system and closed loop control system. The objective of this advanced control system course is to introduce the students to different types of time and frequency response design, and to make them familiar with the different types of stability analysis, which is study the input output response, and to enable the students to understand the modern and optimal control design, and to introduce the student to the non-linear control systems. So what is a control system? So basically control system is a combination and connection of elements and device and mechanism which are desired for some purpose or objective. So there is some input which passes through the system, and at the end of which we get some output. So in a control system, the desired configuration will provide a desired response. So we can control our input, we can amplify our input, and we can get the desired input. So in control system, basically we will study how input behaves when it passes through a system and how we can control the input so that we can get our desired response. For example, if you want to fill a tank, there is a tank which has an outlet valve and there is an inlet valve. Both are open simultaneously, and the objective is to maintain the level of water in the tank. So the input, there will be some input of water, that is mass in flow rate, and there will be some output. So what mathematical connection between the input and output is required so that we can control the water level in the tank. Also, we want that whenever water level is getting low or dips, so we can get a signal to our machines and actuators that will start a series of actions which will increase the mass flow rate through the inlet, and then we can again gain the desired water level. So in control system there is an input output, and in between there is a system of process. The process can be a electronic device, a plant, a system, a flywheel, a biological system, a human brain system. For example, uh, if the bacteria levels or growth become to the level of hazard in the blood, the actuators and signals will activate the brain to heat up the body, and we will get the fever. So, a process we need to have under control, and that's why we have to have a relationship between the input and output. So where we can find control system, basically control systems are everywhere. For example, in home heating system, in hospital, in automatic cars. So the principle of controls have an impact in the many field of engineering, aeronautics, space vehicle, even economics, biology, and medicine. So, for example, home heating system, the input is the resistance coil which heats up, and the output is uh, the temperature sensing instrument which gives us the output of the home. So if you want to maintain the temperature of the home at 35 degrees Celsius, we have to control our input and we have to have control over our desired output. So that is why a control mechanism come into picture where it can sense the home temperature, and if the temperature is more than the required, it will signal the power devices to reduce the current and voltage, that is so that the power generation may reduce, or it may turn off the heating coil. Why we need control system? Because today's in we use high-end device like for example we send Mars to the Mars Land Rover, we send a space vehicle in the universe, we send robots which works without man, and we send guided missile system which track the target and hit it. So the control systems applications are everywhere. For example, the numerical control of machine tools in manufacturing engineering, where we want to control the cutting process, and we have to have a feedback system so that we can obtain the good quality of the products. Another example is the autopilot systems in cars and aerospace engineering, where we want to a car without man. So a car will sense the other moving object, and it will signal to its system that so that a decision will be taken whether to take a turn and whether to execute brake, etc. So such a systems are in use in from the ancient times like water clock, like water leveling bowl, etc. And in the modern times, the first modern control system was speed governors, where we want to control the speed of the steam engine. So also in industrial operation, we want to control pressure. Suppose in a boiler, we want to control pressure. So we have to have some sensor, some devices which can gauge the pressure inside the boiler. And if the boiler pressure is above the danger level, it should sense and to some pressure diffusing mechanism should open. Similarly, we want to control temperature, humidity, viscosity, and the fluid flow rate in sometimes, like the paper pulping industry, we want to control the flow rate, etc. Also, there are some dynamic systems whose characteristics are changing with time. So we have to have understanding of the input and output response and how an input behaves in a dynamic systems. So such an analysis improves productivity and thus defend us from the various repetitive manual operations. So an example of control system can be found in automatic water leveler control. So there is a fulcrum, there is a supply valve, and when the part is open, the fluid flow enters into the main container, and the float rises, and thus when the desired level is achieved, the float hits the fulcrum, and thus the supply valve stops. Another example is the automatic engine speed controller, which use fly balls. So we have already studied about it, how the flywheels move away because of the centrifugal force. If the speed is high and the sleeves moves up and the bevel gear rotates, and thus the supply of any fluid flow rate can be controlled. So such a system is required in automobile engine where we want aero and fluid mixing, so that we can obtain the required air fuel ratio for the proper combustion. And such a flywheel governor are required in a steam engine, so that if whenever there is a excess fuel supply or steam supply in this case, so we can reduce the rate of steam supply, and whenever there is a decrease in fuel supply, so we can control the fuel supply or steam in this case. Now we will talk about the concept of control system. So what is a control system? So basically a control system is a system in which some preset characteristic is required, and we do not need some operator or human actions. So everything should take its role and play sufficiently so that our output is as per the desired value. So the in control system, we can say that it is the regulation of process without the human intervention. The system is designed in such a way that it takes care of itself. So a control system has variables. There are two process variables involved. So one is a control variable and another is a manipulated variable. So a control variable is maintained at a specified value or within a range. For example, the supply of the steam to a steam engine, or the supply of water to a fuel tank, or the supply of current to a circuit. So the storage tank level is a controlled variable. So that variable we want to control. A manipulated variable is the process variable that maintains the control variable at the desired value or within the desired range of values. So a control variable is the desired, and by the which operations and sequences of operations the which variable is manipulated to gain our control variable at the desired specific range. For example, the flow rate of water supplied to a tank is the manipulated variable, which can be manipulated to obtain our control variable, that is the level of water to a desired value. The function of automatic control or control system is basically there are four functions of a control system. The control system can measure the input response, and it can compare the input response with any previous values, and it can calculate and compute the input response, and it can make correction based on the feedback, and uh, uh, measuring the error with some reference value. Now let us talk about modern engineering applications of control system. As I have told you, there is an immense need of controlling systems, especially electronic systems like our modern aircraft and military plane, space vehicles, space shuttle, unmanned aerial vehicles, drone, etc. They are called fly-by-wire because everything is controlled by the signals, right? Robotics is another field where we can see a huge application of control system. So control systems provide high accuracy of and positioning for manufacturing. Arms of a robot can build at the fixed spot and with accuracy. So robots also can work in a remote environment. We can control from some another station. Robots can work on space. Robots can work inside the sea. And robots can perform surgery also. In chemical process control, we want to control the rate of chemical reaction, concentration, temperature, etc. So we want to regulate flow rates. In communication and networks, amplifiers and repeaters uses the theory of control system. So whenever there is a congestion of internet, we need a control system which can efficiently work so that the congestion is reduced. Another example is the power management for wireless communication. Also, we use in the engine. Modern automotive vehicles use control system for the injection, for the air fuel mixing, and the controlling the proper turbulence inside the engine. In addition to the examples given above, we can find the control system inside our body. There are biomolecular regulatory networks which control the secretions of hormones. There are physiological regulation like homeostasis. You can find also the control system in environment like the global carbon cycle, the rain system. So whenever there is a great humidity and temperature rise, so the water from the ocean evaporate and the rain can happen. Also in financial systems, we can use the theory of control by influx and outflux of monetary supply. We want to control the supply and service chains. We want to have uh, we want to have study the market and exchanges, how it behave to some stimulus. So in modern economic system, we also develop mathematical models which can control and and we can have a desired output or response. A brief history of control systems. So control system controlling things is very old. So one of the ancient example is an elementary water clock in which we use a float and the float moves up and down based on the level of the water in the container. And another modern example of the control system is the governor, fly ball governor of James Watt, which works in a steam engine. You have seen it and we have discussed it. This is the first modern controller and it is used to regulate the speed of the steam engine by controlling the steam flow rate. And how it controls the steam of the flow rate, we have seen that using a fly ball, the fly balls rotate and the sleeve moves and up and down. And also it is used to reduce the effect of variance in load in conjunction with a flywheel, because the flywheel have heavy inertia, so they can absorb the fluctuations. This is needed because any power fluctuation is detrimental to our the product. So modern control theory begins in 1840 by G.B. Airy. He was the first to discuss the instability in a feedback control system. He proposed some mathematical analysis, studied the input and output response, and he analyzed such system using the differential equation. In 1868, Maxwell systematically studied the stability of feedback control, how a feedback is given to the input response, and it can unstabilize the system. Routh derived the stability criteria for linear system in 1877, and Lyapunov in 1892 proposed that the stability criteria that can be applied to both the linear and nonlinear differential equations results that was not introduced in control literature until in about 1958. So modern control system design methods begins by Nyquist in 1932. He developed a simple approach to determine stability by using plots and graphs, analyzing the loop frequency response. After 7 years, Bode introduced a frequency response method to analyze the response of an input to output, which is known as the Bode plot today. And Evans developed a root locus method to assess the stability of the control system. So these methods, after studying, we can design control system, but there are much more in the depth about the control system. So our control system can be acceptable using these techniques, but may not be optimal. So modern control systems and control theory are applied also in engineering systems, biological, biomedical, economics, and financial, as I have discussed. These are the references of modern control engineering by Ogata, control system engineering, U.A. Bakshi, control systems by Bolton. These are the references of modern control engineering by Ogata, control system engineering, U.A. Bakshi, control systems by Bolton.